Hi everyone, welcome back, and today we are going to see about the Electro Dynamo type wattmeter. So the purpose of the various instrument, the ammeter which is used to measure current, voltmeter which is used to measure voltage, wattmeter which is used to measure power in electrical circuits. Power. So normally in power it is defined as the ability or the capacity to do something, that is called power. So here the power is denoted called the product of voltage and current. So here the power can be measured by using the wattmeter. The power can be measured by using the wattmeter. So here we are using the several type of wattmeter. One is dynamo type wattmeter and induction wattmeter, and the third one is electrostatic wattmeter. So apart from all these three, we can go for the electro dynamo type wattmeter. So here the dynamo type wattmeter, it consists of two coil. One is called current coil and another one is called voltage coil. So it is also called as fixed coil. Fixed coil means it is called current coil and the moving coil is called voltage coil. So the P, it represents the pointer. We will see the diagram. So here the source. Here it is the source. It is the source. Here we are supplying the single phase power supply. Here we are supplying the single phase power supply. So here the current which is entering into the load, initially it coming from the line which is entering into the first fixed coil, then after that it is going to the second fixed coil, from the second fixed coil into the load, and the load again it is connected with the neutral. So here the current is flowing through two fixed coil. Normally it has only one fixed coil, then it is divided into two off. One fixed coil, it is divided into two off. So here in wattmeter it has two off fixed coil. The fixed coil is divided into two sections. Okay, so the fixed coil is connected in series with the load. The fixed coils are connected in series with a load. Okay, and next one, the moving coil. Here you can see it is the moving coil which is connected across the load or across the source. The moving coil which is connected across the source, or it is called load. So the fixed coil is connected in series with the load, and the moving coil which is connected in parallel with load or source. Okay, so here the fixed coil is called current coil. So the current coil which is able to carry the current which is supplied into the load. And the moving coil is nothing but pressure coil or potential coil, or it may be called as a voltage coil, which is connected across the load, or it may be called source. Okay, so in the moving coil only we are connecting the spindle as well as pointer. So the pointer, below the pointer there will be a uniform scale will be there. That is uniform or not, that is a ununiform scale will be there. That is for AC measurement we are having the ununiform scale will be there. Okay, now while supplying the current to this fixed coil and moving coil, so the fixed coil is getting energization and it acts as an electromagnet. Okay, so now then it start producing the electromagnetic fluxes. But the moving coil, so based on the attraction of the fluxes which is produced by the fixed coil, so based on that the moving coil gets aligning with the fixed coil. So when the moving coil gets moving, the spindle gets moving, so the pointer also gets moving, so that we can get the deflection. So based on the deflection we can able to measure some amount of power. So what is the actual value of power which is consumed by the electric circuits? And in series with the moving coil there will be a resistance. So the resistance, it provides the high resistive passage, so that we can able to minimize the large amount of current flowing through the moving coil. So this is the working principle of dynamo type wattmeter. So based on the interaction of flux, based on the interaction of the fixed coil and moving coil, so the pointer gets moving. So this is an assessment. The power is dash, rate of doing work, or rate of producing voltage, or rate of generating current, or rate of overcoming friction. And the second one, in DC circuit, power is measured by using ohm meter and galvanometer. Second, ohm meter and voltmeter, ammeter and voltmeter, ammeter and galvanometer. So you can put your answer in the comment section, and this is the calibration. This is the every instrument during the certain amount of time duration we have to go for the calibration, so that only we can able to measure it read and it observe the correct reading. We can able to measure the current reading only, so that it is definitely we have to go for the calibration. And it has some errors, that is called observational error, grass error, random error, and climate error. So there are a lot of errors has to be indicated. Okay, so that has to be monitored and simultaneously. And these are the advantages. The scale of the instrument is uniform, high degree of accuracy will be there. But what is the disadvantage? The error due to the inductance of pressure coil, so that the power factor is very serious, and stray field may affect the reading of instrument. So these are the advantages and disadvantages of Electro Dynamo type wattmeter. And this is the second assessment. A wattmeter consists of current coil and a potential coil, whether it's true or false. And second one, in a dynamo type wattmeter, the fixed coil is split into 1, 2, 3 or 4. And list the advantage of Electro Dynamo type wattmeter. So you can put all the answers in the comment section, and these are the few references. Thank you.